Hello everyone, welcome back to my class. Today's topic will be centered around the trigonometric ratio. Don't forget in our last class, I taught you about the Pythagorean rule. Do you still remember that? Good, very good. But today we'll be dealing with the trigonometric ratio. Say it after me, good, trigonometric ratio. So in a trigonometric ratio, the first thing we need to establish today in this topic is this. We are going to draw a right angle triangle. This is a right angle triangle. I explained that to you in our last class. Let's say this is A, this is B, and this is C. This is angle C, and this is angle A. So the first thing, we need to name each of these sides. If this is C, automatically the name of this side is going to be C. If this is angle A, automatically the name of this angle is going to be A. And don't forget we are using the small letter as we are saying. And if this is B, this side is going to be B. That is, we are using the letter that faces the angle. Are you following me? Now, this longest side or the side facing the right angle is called the hypotenuse, as I've explained from my previous class. And the other two sides can either be opposite or the adjacent, depending on where the angle is. If it is angle A, automatically A is going to be the opposite because it's the side that is facing the angle A. And if A is opposite, this side is going to be the adjacent. And if it is angle C, automatically C is going to be the opposite. And if C is the opposite, automatically A is going to be the adjacent. So opposite and adjacent, it depends on where the angle is. Do you get that? Good. Now, the next thing we are going to get into is the formula for this ratio. We have the formula for this ratio. And a simple way to remember this formula is what I call the SOHCAHTOA. SOHCAHTOA. Now, let's explain that. You might be thinking probably I'm speaking rubbish or something. Now, let me explain the concept of SOHCAHTOA. This is SOHCAHTOA. This is so, this is ka, and this is toa. Now, for so is for this S stand for sine. So I can say sine A. Sine A is equal to O stand for opposite. Opposite over H stand for hypotenuse. Are you getting me? Then for the card, C stand for cosine. So cosine is equal to A for adjacent over H for hypotenuse. And the last one is TOA. T is standing for tangent. That is, tan is equal to O is for opposite and A is for adjacent. So these are the three basic formula that we are going to be using in this trigonometric ratio. The first one is so, which is sine A or sine theta is equal to opposite over hypotenuse. And K goes for cos or cosine theta is equal to adjacent over hypotenuse. And TOA goes for tangent theta or tan theta is equal to opposite over adjacent. Now, the next thing we need to establish from here is that from this our diagram, we want to use this formula to form a formula from this right angle triangle. Now, let's go for the first one. If I say sine A, don't forget this A. Sine A, our formula is so, which is opposite over hypotenuse. So sine A is equal to the opposite side of this angle is A over, and the hypotenuse is the longest side of the right angle, which is over B. And the next one, if I say cos A, don't forget cos, we are using K, which is adjacent over hypotenuse. So cos A, this is A also. If this is opposite, automatically C is the adjacent. So cos A is equal to C over the hypotenuse, which is B. C over B. And the next one is tan A. Tan A, don't forget, tan, we are using toi, which is opposite over adjacent. So the opposite of A, of angle A is A, that is equal to A over, and the adjacent is C. So A over C. Now, let's look at something else. If I now said sine C, we have finished using this angle. Let's use this angle and let's see what is going to happen. So sine C is also opposite over hypotenuse, which is C. Sine C is equal to C over hypotenuse, which is B. And the next one is cos C. If this cos C is adjacent over hypotenuse. So this is the opposite of angle C, and this is the adjacent, which is A over hypotenuse is B. And the last one is tan C. It is tan, that is toi, which is going to be opposite, which is C over adjacent, which is A. Now, if we look at this formula very closely, we can see that sine A, which is A over B, is also equal to cos C. So sine A is equal to cos C. That is, we can write it as sine A is equal to cos C, which is equals to A over B. I'm still going to explain that one later in a clear term. So we can also see that cos A and sine C is the same thing. So we can also say cos A is equals to sine C, which is equals to C over B. Are you getting what I'm saying? Now, let me implement another right angle triangle. This is a right angle triangle. This is 90. If this is A, B, and C. Now, the first thing you need to know is also that angle A and angle C are complementary. The sum of angle A and on angle C, they are complementary. When we say complementary angle, what we are talking about is that any two angles that you add together, that it gives us 90 degrees. We call it complementary angle. Do you get that? So we can say, if assuming this plane is theta, if this is theta, automatically C is going to be, so far the addition of A and C, angle A and angle C give us 90 degrees. So we can say angle C is going to be 90 minus theta. Are you following me? So angle A is theta, automatically angle C is going to be 90 minus theta. That is, we can also set sine A or sine theta. Sine theta is going to be, don't forget, the side here is small letter A, the side here is C, and the side here is B. So sine theta is going to be cos 90 minus theta, which is equal to what? A over B. So sine theta is going to be cos 90 minus theta, which is equals to A over B.